The purpose of this video is to provide a brief description of an analysis of queues for cyclists and their interaction with pedestrians at an intersection in Barcelona, capital of the autonomous community of Catalonia in Spain. Specifically, we will analyze the queues formed by cyclists at one of the intersections in Plaça Francesc Macià. When looking at the street view, it's possible to see the convergence that occurs between people on bikes and on foot. We observed the intersection on numerous occasions and took note of the specific times during the day when traffic was visibly high. Through this analysis, we determined that the rush hour for this intersection was from 8 to 10 on Monday-Friday. The first day of measurements was on Thursday, November 27th, 2025, within an hour span between 9 and 10 in the morning. Using a clicker on handheld devices, we were able to track the exact number of arrivals, departures, and traffic signal status at the intersection in real time. The second day of measuring cyclist and pedestrian flows was on Wednesday, December 3rd, 2025, between 9 and 10 in the morning. Here in the video, you can see the interaction between both flows, as well as some team members quantifying these movements on their digital devices. The information collected from both days was stored in an Excel file that includes the arrivals and departures of cyclists, as well as the pedestrian counts and the crosswalk signal phases. 38 samples of cyclists traveling under free-flow conditions were taken in order to later obtain the free-flow travel time. Additionally, 3 charts, pedestrian groups, arrivals, and departures were created to preliminarily visualize the information. To better understand the situation, our team carried out several bicycle rides at both free-flow speed and congested speed. The route is very well signposted and also has cyclist traffic lights. The bike lane is separated from vehicle traffic. Everything is going very well until a surprise. We come across these utility access covers right at the entrance to the plaza, leaving only a small space free for a smooth ride. Then, the right-hand turn is really closed. Cyclists coming from the opposite direction also encounter this type of public utility covers on the ground. Now, let's review the situation at congested speed. In this case, I'm part of the queue. Also, you can see some cyclists coming in the opposite direction of the bike lane and a significant number of pedestrians crossing the street. Since I was part of the last cyclist, I didn't have to merge with pedestrians, but the cyclist in front of me did, like this guy on his electric scooter. Normally, if a pedestrian and a cyclist see each other, there is a mini negotiation time while moving to figure it out who goes and when. You as a cyclist have 2 options, either speed up and go ahead or just go behind the pedestrians. Here you can see 3 cyclists trying to continue their journey amongst some pedestrians. Here there is another example of cyclists riding at congested speed. These ones literally had to come to a complete stop because the pedestrians were blocking their flow. At the node, there are a total of 20 conflict points. Let's talk a bit about them. The solid lines represent cyclist flows and the dashed lines represent pedestrian flows. The 6 white circles are conflict points between pedestrians. The next 6 yellow circles are conflicts only between cyclists. And the 8 black circles are conflicts between pedestrians and cyclists. These are the most dangerous ones. Specifically, we will analyze the conflicts of red flows against yellow and blue flows. For the data analysis, a multi-step process was followed. Initially, missing data was imputed to clean and prepare the raw data. Next, the virtual arrival time was created for each cyclist by shifting the observed arrival time by the estimated free flow travel time. This represents the time at which a cyclist will enter the system without any disruptions. Using the observed departures and the constructed virtual arrivals, the cumulative arrival-departure curves were generated to visualize the system dynamics and queue formation. Key metrics such as total delay, average excess accumulation, maximum excess accumulation, average delay, maximum delay, and average delay rate were calculated using these curves and the queuing theory equations. To evaluate the impact of pedestrian volumes on cyclist travel time, additional statistical analysis was performed. With this, we conclude this video where we explain the procedure our team used to collect and analyze the field data for this mini project in the Operation and Management of Transport Systems class. For more information, we invite you to check the website, where you will not only see our work, but also that of our classmates from this and previous terms. You can find the link in the video description below. Bye for now. Universitat Politècnica de Catalunya, Barcelona Tech.